Hello everyone, welcome back to another episode of Tantra's Mantra where we go behind and beyond the tech news headlines. I am Prakash Sangam, founder of Tantra Analyst and your host. Today we will discuss the chip shortage that has marred the industry for more than a year now. This acute shortage has made everybody realize how chips touch almost every aspect of our lives, be it automotives, smartphones, computers, cameras, sensors, and all the IoT devices at our homes and so on. The shortage put a sharp focus on semiconductor supply chain as well. Everybody is now trying to understand how it works, why it went into a tailspin recently, what is needed to recover from the current situation, and most importantly, when will we come out of this supply squeeze that we are seeing now. Actually, Qualcomm commissioned a study through Accenture to explore various aspects of a semiconductor value chain, the reasons behind this supply shortage, and advise the industry on how to come out of it. Accenture subsequently published a comprehensive report, which is more than 100 pages long. I read through all of them. It indeed is a very insightful and informative report. Even though I have been in the semi industry for more than 20 years, I still found a few tidbits that I was not aware of. I'll include a link to the full report in the description of this podcast. I highly encourage you guys to check it out. So, to discuss this report, we have two prominent personalities with us today. First one is Timothy Chu, who is one of the authors of this report. He is a senior manager in Accenture's high tech semiconductor practice. Tim, welcome to the show.
Thank you. Thanks for having me.
All right, and then with him we have Falan Yinug, who is director of economic strategy at Qualcomm. Falan, welcome to the show.
Thanks, Prakash. Thanks for having me. Really appreciate it.
Perfect. So let's get started with some quick introductions. Let's start with Falan. Falan, why don't you tell us about your background and what you do at Qualcomm?
Yeah, sure. So at Qualcomm, I work with the global economics team, which is sort of the in-house think tank led by our chief economist at Qualcomm. And I mainly focus on semiconductor supply chain issues and the semiconductor market and industry writ large. Just a bit of background. I'm relatively new to Qualcomm, having joined in October of last year. Prior, I was the chief economist at the Semiconductor Industry Association since 2012. And then prior to that, I got my start in covering and analyzing the semiconductor industry and market with the U.S. government with an agency called the U.S. International Trade Commission starting in 2003. So almost 20 years now, I've been sort of focusing on semiconductor issues. So it's been a long time.
Well, yeah, that indeed is a long time, and you're the right person to address the issue that we have at hand today. Tim?
Sure. Thank you. So, as previously mentioned, I'm a senior manager in Accenture's high-tech strategy semiconductor practice. In this practice, I've been in this role for close to a decade, where we focus on industry trends, growth strategy, and then more enthusiastically, the technology trends associated with this industry, and advise our clients accordingly. Additionally, prior to Accenture, I spent close to another decade in semiconductor manufacturing directly. Right? So direct hands-on experience seeing how these products are made and how they end up in consumers' hand has been very insightful in helping inform our strategy at Accenture.
Very well. Thank you both for coming to the show. Let's jump on to the study and the report. So, some basics first. So, what was the primary objective of this study and the report, and what are some of the key findings that you saw when doing the study?
I'll kind of take a first crack at answering this question, and Falan, feel free to chime in with your perspective as well, right? We were first approached by Qualcomm to partner with them on this particular paper due to the increased visibility in the semi industry in today's environment specifically. We were really excited to partner with them, and where we landed was to come up with a comprehensive study that fully encapsulates everything involved in the semiconductor value chain, not the supply chain. Right? So we thought it was a very important distinction and one that was the primary driver for this paper.
Okay, and how do you differentiate between the value and supply chain?
Yeah, so supply chain is definitely front and center in public perception, right? Because it determines or it refers specifically to the ability to procure products in silicon that are necessary for the end user. When we talk about the value chain, we wanted to go deeper into it, right? So beyond just the actual supply, what parts of the semiconductor process and the semiconductor industry are bringing value to the end customer, right? So it starts all the way back from raw materials into the equipment providers, into the R&D associated with designing the chips,
Mm-hmm.
the corresponding R&D associated with the process technology, and all the enablement that is necessary to drive supply.
Okay.
And Prakash, I would just say, I think, this report has come at really the right time. I think over the past year to 2 years, there's been just an intense focus on learning about the semiconductor industry and how it works. And I think this report sort of explains that and the distinction between just simply thinking about the global supply chain for semiconductors, and as Tim mentioned, talking more nuanced in a more nuanced manner about the value chain that's created along that supply chain. I think it's been a real great sort of value add of the report's findings.
Yeah, I agree. I mean, a lot of people don't realize how industry is not just the main line in the supply chain, but how many other industries connecting to this, right? It was a revelation for me as well, reading the full report, right? So,
Oh my gosh.
chemicals and the others, and people think, okay, there are chipset suppliers, there are fabs
Yeah,
and such, right? But there's so much goes into the ecosystem as such in making the chips possible.
it's incredibly complicated,
Uh-huh.
and I think the report really helps to explain just how complicated and interdependent and globally oriented the industry is and has been for decades, right? And so, it's sort of an industry that requires a fine-tuned, delicate balance to operate smoothly in this global environment, and done so quite successfully in the long term. And obviously there's been short-term disruptions to that, which we can get into, but I think that has been sort of very helpful in educating the general public about just how complicated making a chip is.
Yeah, indeed, indeed. So let's jump into this chip shortage right in. Yeah, in my view, it was a perfect storm, right? There's global pandemic happening. There are tons of geopolitical issues. There is a war that started in the way, and now inflation is hitting. So, do you think all of these other external things further exacerbated the already fragile semi supply chain?
Yeah, so it's a really great question. What I'd like to say is that the semiconductor supply chain, it's always been built on a knife's edge, right? It's the inherent nature of semiconductor economics,
Mm-hmm.
right? The high cost of R&D, the high cost of manufacturing. You couple that with effectively 5 to 7 year long lead times
Uh-huh.
in the demand signal between the end customer and where you really start to impact change in the value chain. That results in the value chain being built to be as optimized and efficient as possible.
Uh-huh.
Right now, the flip side is, as you call out, right, these characteristics, when you couple them with the longer lead times and the associated signals from the end user, the way that ripples all the way back to manufacturing, that results in a supply chain that dramatically overreacts to disruption, whether it's positive or negative disruption,
Uh-huh.
right? And that overreaction propagates through the entire value chain in a very profound way. You called it a perfect storm, and one of the key statements in the paper is that COVID-19 or the pandemic, right? It did not cause the supply chain issues. It really exacerbated supply chain issues in an industry that is primed to these sort of ripple effects.
Oh yeah, I mean it was so fragile. It was, as you said, on the knife edge. All it needed was a small push, and we had many small, not just small, many large pushes to really push it to the brink of this collapse, as you've seen.
I don't know if I would call the supply chain fragile specifically, right?
Uh huh.
I think the more accurate description would be optimized, right? Because it's optimized for the economics of the semiconductor industry. It's
Yeah,
not
true.
really
Yeah.
fragile. It is the nature of the business to have these kinds of long demand signals that take time to manifest themselves through each stage of the value chain.
Okay. Yeah, that's true. Yeah, Falan.
I would just add one thing. I think perfect storm certainly helps characterize it. One unique aspect I think of over the past couple of years of what's happened is and I think Tim has alluded to this, is the demand environment, right? I think usually the industry is pretty good at meeting demand and trying to, sort of get supply right when demand is understood and when demand is expected and the forecast is pretty clear. So what we saw over the past couple of years is what I like to say is unprecedented and unanticipated levels of demand, right? And that's basically because society just shifted in terms of how it behaved, right? We had school from home, work from home. People were starting to use Zoom and Teams and all these other platforms that weren't anticipated, right? And so that put a lot of unanticipated and unprecedented increase in demand. And so that's, in my mind, what has been unique about over the past couple of years issue with the chip shortage is it's not because the industry has refused to or has not actually increased levels of capacity. It has actually to be, unprecedented levels of added capacity. In fact, last year in 2021, the industry sold more chips than in any other year previous. Over 1 trillion units of chips were sold in 2021. That's only the second time in the history of the industry that the industry has actually sold over 1 trillion units in 1 year. So the industry has tried to meet demand by successfully increasing supply. It just hasn't been able to increase it to the unprecedented levels of demand that has existed.
Yeah, true. And it's like there was increased demand and then there are supply interruptions. Okay. So one thing it is really interesting is that the chip shortage is across the board, across every industry, but it is felt much more in automotive than say smartphones or PCs. For example, the iPhones, they are able to announce and launch the iPhones they did before. Same with say, Galaxy phones, their cadence is the same as before. Even Qualcomm chips, for that matter, are being announced and launched the way they were before. But when you look at automotives, the shortage is really, really acute. People really feel it. Why do you think is that the case?
Yeah, so I think there are a couple of factors that play into this, and it's a very astute observation, right? So first, it's the type of technology involved in the design and manufacturing of the chips between iPhone and Androids, right? That technology utilizes newer, more advanced processes, right? The investment has already been made to create this capability, and the high cost of R&D to necessitate that capability also requires the high prices and premium prioritization necessary to make that production financially viable, right? Now, when you look at the automotive industry, it behaves slightly different, right? And the reason it behaves differently is a direct result of the industry and the customers they service, right? I think it's probably not a controversial statement to say that cars are expected to last longer than mobile phones,
Indeed,
right?
yeah.
And so almost as a requirement, the silicon technology that goes into cars have to be qualified, have to be designed in a very different manner, right? And I think the second factor is almost an extension of the first point, and Falan actually touched on this briefly. It's how manufacturing capacity is planned. The history of the industry, where mobile was and still is a very large part of the market, is where the prioritization for planning and capacity expansion exists. And with the automotive industry, it's relatively smaller in raw capacity expectations, but it's much higher in growth. And you couple that characteristic with the planning timelines that can be a lot longer.
Okay.
You can see how the demand signals within that industry specifically have resulted in kind of this divergence in ability to meet demand.
I see.
Another thing too, I would add, Prakash, Tim certainly nailed it on the head in terms of sort of describing what's unique about the automotive industry. I would just add a couple other things as an end market. Tim mentioned it's not a controversial statement to say that cars are supposed to last longer and requirements for chips are different. There's the safety issue. Cars, obviously, chips need to last and need to perform at a much higher level. Qualifying the equipment that even makes auto chips is a long process, right? So, in terms of in a fab, what is making auto chips has to have a higher level of not having errors than, say, other types of products that may be more consumer facing and less safety, that may have less of a safety component to that end product. So that's one thing. The second thing, too, through, and the report really spells this out in really nice detail, is auto as an end market tends to have higher concentration of legacy chips that are needed, right? Analog, think of analog chips or discrete products that may not be needed to be built on, leading process technology nodes, right? So think of,
Hmm.
legacy nodes, 90 nanometer, 180 nanometer, or even older. There's a lot of chips in many systems in a car. I think the report mentioned maybe over like 70% of the actual number of chips in a car, which I think the report mentioned is about 1,000 to maybe 3,500, depending on the type of car, are really made on these legacy nodes. So a lot of during the chip shortage, a lot of the demand was being put on need for the legacy node capacity. And as Tim mentioned, the economics of the industry, there is less incentive, right, for companies, for the industry to add more capacity and for those types of products than there are for leading edge products that can garner higher yield, higher margin, right? So that's just a sort of function of the industries, what's needed for the industry and the incentives and the economics of the industry.
That's interesting and counterintuitive, right? You would think that there is much higher demand for the latest nodes, and you can see, okay, there is supply disruption, and because of that shortage there. But you're saying there is less of an investment because of lower margins in these mature nodes, but most of these mature nodes go into automotive and there's no investment going, and that's kind of is the reason behind extreme short squeeze on automotives. That's kind of very counterintuitive in my view.
I was going to say, I think this speaks to a very profound point
Hmm.
that we wanted to make in the paper is that supply is not fungible, right? You can't just move supply from one node to another.
That's a great point.
As far as the general public is concerned, right? If they don't get a car and they think, well, there's a chip shortage, what's really important to understand is that chip shortage must be seen as a solution-oriented shortage, right? So when Falan says there's 1,000 to 3,500 chips in an automobile,
Hmm.
you miss out on 100 of those chips. You don't have the solution you need for that car.
True.
Conversely, in a smartphone, there's about 170 different types of chips in a smartphone. So there's just more opportunity in a more diverse field of supply for something to go wrong. And then you add to that the fact that supply isn't fungible. You can definitely see how automotive specifically was an industry that got hit much more dramatically with a disruption.
Prakash, one number that sort of sticks in my mind from looking at sort of industry market numbers for a while, its value of of the semiconductor market is about, depending on from year to year, 80 to 85% IC, which is sort of the higher end type of semiconductor compared to discrete products, right, which are sort of lower end.
Hmm.
So think of 80% of, say, a $500 billion market, 80% of that value in dollars is comprised of selling of ICs, memory chips,
Hmm.
microprocessors,
Hmm.
logic chips, all the sort of high value, many transistors on a chip kind of product. Conversely,
Hmm.
it's just the reverse in terms of the actual number of units sold in the world. So in terms of the number of units sold, usually between 80 to 85% of the total number of units sold are discrete products,
Hmm.
are really cheap products, right? That don't cost that much, are like ubiquitous in the world. And 20% or so are are actual ICs. So the world is much more full of discrete products, and it's sort of balanced out in sort of the number of chips in an average car, which you have about 70% of the are discrete products, very low value, maybe costing 5 cents, a cent, or not much. And the other 20% is 20 to 30% would be ICs. So when you have a shortage, you need, like Tim said, you need the whole suite of chips for a car, the whole 1,000 to 3,500. You're likely going to be short the 80% of the actual units of the discrete products, the lower value chips that don't cost that much, but you still need the whole suite of chips for your car to work and to sell a car. So I thought that was always interesting, the difference between the 80 and 20% in terms of the value of the market and in terms of the number of the types of units sold.
That indeed is very revealing, right? I mean, nobody would expect that because most of the time everybody is focused on the latest node. When is the latest node coming? Who will supply? What is the yield, and so on? But the crux is in the mature nodes and the supply thereof. That kinds of sets the stage very right for my next question, which is the reaction in terms of solving this shortage. As noted in the report, many governments in the world seem to think self sufficiency is the answer to this and investing heavily in setting up fabs and so on. And that's great. But I think that only addresses the one specific issue of fabs. But the issue is much larger, right? I mean, the semiconductor supply chain is much more than just fabs. So, what do you think? Does just focusing on fabs, paying companies to deploy fabs, especially in the latest nodes, would that help in solving this issue?
So it's a really interesting question, and one that I worry we don't have the proper amount of time to thoroughly address.
Uh huh.
So what I will say is, we were very specific in our paper to ensure that the language we use was value chain, not supply chain,
Okay.
right? And so the cost of manufacturing, supply, they're all associated with underlying technology.
Mm-hmm.
And what the industry has done is create kind of this virtuous cycle of collaboration between design and manufacturing,
Mm-hmm.
right? So your design houses that partner and collaborate with manufacturing. It isn't just a design that you lob over into manufacturing.
Mm-hmm.
There is a collaboration and development process in partnership with your supplier to ensure that your design is feasible economically.
Mm-hmm.
And that kind of reinforces my previous statement around how supply isn't necessarily immediately fungible, right?
Okay.
And so with this kind of emphasis on supply specifically, you do risk offsetting kind of the equilibrium that globalization of the industry has kind of naturally evolved into. Do I believe it'll help address the challenges? Potentially, yes, right? Because supply is top of mind. But we wanted to be very clear in our paper that it really is one part of a very complex equation.
Mm-hmm.
Yeah, I would totally agree. I think, well, it depends on what you're trying to solve for. I think obviously there have been, and I think the report has a whole chapter and really sort of drills into this. There has been, as the industry has evolved, there have been specialization and areas where have become sort of choke points, or areas where there's a high concentration of a certain activity within the global value chain for semiconductors in a specific region or in a specific country. For example, I think the report outlines that the vast majority of front-end fabrication capacity, over 70%, is now in Asia and not in the US. And so if you're trying to solve for creating some sort of resiliency or redundancy within the value chain to say, okay, well, we want to have other options, or be sure that there's not just one location or one company or a handful of companies that are only doing one piece of the supply chain that could create a bottleneck or a choke point, then yes, adding more capacity for manufacturing is important, given what we've just gone through over the past couple of years, right? At the same time, though, and I think this is the difference, again, which both Tim and I have sort of alluded to, when you talk about the value chain instead of the supply chain, then you're talking about trying to also be sure that you don't shortchange innovation, right? And shortchange trying to invest in maintaining innovation.
Mm-hmm.
Certainly in the design side of the equation, even the process technology side, right? The industry, semiconductors, Moore's law, innovation is just, sort of part of how the industry operates. And it's important that there's still investment in trying to continue to innovate and enable, therefore, downstream industries in the way that the industry has just done in a spectacular manner over the past several decades, right? So I think that's sort of the balance. Yes, manufacturing is important to think of, especially in the short term, of how do we consider how to build resiliency so that we don't have a situation where there are these choke points of only one or two locations or companies that are doing a critical component, but also look at the bigger picture of, hey, how do we be sure that we're still incentivizing and promoting innovation overall in terms of R&D, design especially, and even process technology.
Yeah, cool.
There's a really interesting balance we have to strike between our use of the term short term as well, right? Because we are making immediate investments domestically, at least, in building up manufacturing capacity. And when we say short term, this is capacity that likely won't come online for another 3 to 5 years,
Yeah, true.
right? And that coming online is in partnership with design houses. The building of the facility, of the manufacturing capability, you don't realize the advantages of those until you have ecosystem partners who work with you to establish the process technology associated with the products that you ultimately want to push out of your fab.
Yeah.
Right. So when we say short term, it's still actually a very long game.
Do you see that this investment is going on not just at the top end of the node, but also at the mature nodes?
Well, I think it still remains to be seen. I think there is a potential, certainly what governments have proposed doing, efforts to look broadly. And I think from the point of view of Qualcomm, I think, in terms of on the manufacturing side, trying to invest, add capacity both on the leading edge and the legacy node is really important. That's in terms of, obviously what we make, but also in terms of where the chip shortage has really felt the most pain, right? And I think, as I alluded to earlier, there's less of an incentive because of costs, profit, to invest in legacy node capacity or 200 millimeter fabs, for example, that sort of focus on this. So this is, in fact, what I should be considered as part of the components in a incentive program that any government should really think about, is how to incentivize that that legacy capacity production, just given the fact that there may be sort of a market failure there, right? Again, there's just less of an incentive to add capacity in that area. So if there was some sort of way that governments were able to create more of an incentive to do so, that I think would help alleviate any potential disruption going forward, given how prominent legacy chips are in end products, as we just discussed, like in a car or a cell phone, where the vast majority of the content of the number of the actual chip units are non-IC discrete products.
Yeah, that's a great suggestion. And I think the report has many other suggestions as well. Could you briefly explain them?
Yeah, absolutely. So, one of the key topics that we touch on is the idea of protectionism versus Moore's law, right? There are, without a doubt, productive ways to invest regionally, productive ways to stimulate growth within the industry strategically, right? And the general direction of the paper is to advise on the effectiveness of that strategy versus what could be seen as counterproductive, right? And when I say counterproductive, I mean anything that limits collaboration. This is an industry with a lot of key players. It's an industry that makes very large bets, right? And these companies cannot continue to make these large bets and only have them pay out 1 out of 10 times, right? That's not a sustainable business model.
Yeah.
So collaboration within the concept of a semiconductor ecosystem across the entire value chain is incredibly important. And so anything that limits the ability to collaborate, even within potential competitors, is not necessarily good for innovation or the direction of the industry. I think the second piece that we focus on is the idea of talent, right? Talent is going to be an incredibly critical part of the conversation within the industry over the next decade. The industry's historically had access to kind of a global talent pool based on the way it's built itself globally. And as the world identifies how this industry is going to operate and collaborate both geographically and with other industries, the talent requirements to sustain it will become increasingly specific, right, by the end user, by automotive versus mobile, right? They'll be increasingly restrictive, right? If there is a segmentation of technology, right, and they'll be increasingly competitive as silicon plays a larger and larger role in the overall technology landscape.
Yeah, I would just add, Tim is absolutely right in terms of what he highlighted, especially talent. I would highlight in terms of the messages or actions from the report. I think there were 5 total, but if you boil it down in some ways or bucket them, it's really, I think, 2 really, and they both relate again to the value creation and enabling innovation in the industry. And one is talent, and one is also R&D, right? So those are the two ingredients, right? That you don't want to, or if you were to take them away or to limit them, to reduce them, right? That would actually have a directly negative effect in how the industry could innovate and enable downstream industries, right? The semiconductor industry is just this amazing enabling industry, right? That enables so many end products downstream: cars, cell phones, smartphones, consumer goods. It's just and more and more end products now, right? It's sort of that hardware that just the brains behind all these products, right? So if you limit those two things, the ability to incentivize R&D and to have R&D, and also not enabling talent, then you kind of limit the industry. One point on talent: I think talent has really two components that I think are really important to think about, and I would say for policymakers to also think about. One is STEM, right? In terms of trying to encourage from a very early age interest in math, science, engineering, sort of those types of fields that sort of help create the long-term pipeline for talent within the semiconductor industry with electrical engineers and such, that are really the ones doing this, creating these fantastic products. And the second is high skilled immigration, right? That is something that I think, especially in the US, is, when there's so much demand for talent, that is a much more short-term solution, right? That can readily address some of the talent shortages, in a matter of months or years instead of sort of decades, right? With the long-term investment in STEM, which is rightfully important to do, but maybe a longer-term investment.
Yeah, very well. So now the golden question. I hope you guys have brought your crystal ball to the discussion today. So when do you think or see the chip shortage to end? And what are some of the early indications that will tell us that the squeeze is ending?
Yeah. So that's the $1 million question, right? I don't know if I'm necessarily going to take a specific position
Yeah.
on when the chip shortage will end, but I will say that the entire semiconductor value chain is easily 5 to 7 years deep on any turn,
Mm-hmm.
right? So take that statement as you will. I personally believe it will end before a full demand cycle, and that'll be a combination of basic supply chain improvement initiatives, and then one thing that we haven't touched on is the ingenuity of product companies, right? Because
Mm-hmm.
as this demand signal ripples through the entire value chain, right, the ingenuity of product companies
Mm-hmm.
means that they can create alternative solutions, right? Work with what you can get, mold your products and what you're trying to deliver to the customer to what's available. It'll be really interesting to follow the ebb and flow of that process. As far as early indicators on when we're coming out of this squeeze, I think you know where I'm going with this, but I'd watch the premium tier, right? Not only do they command a manufacturing premium,
Mm-hmm.
but these are the industries who can best adapt quickly to an increasing influx of supply,
Yeah.
right? So that's where we'll see the responses manifesting themselves sooner rather than later.
Yeah, I would add, I'm not too worried.
Okay.
I don't think that's too controversial to say. I'm not too worried that the industry is going to address the demand and increase supply. I think the industry has demonstrated over its history its ability to increase supply to meet demand. The industry is highly cyclical, but it does take time, and I think that is something that I think certainly the report has shown. And I think we've that over the past year or so has become more clear in people's minds. I've said over the past several months, there's no such thing as a pop-up fab, right? You don't just, sort of say, oh, there's increased demand in this country. Let's just build a fab in a matter of weeks and, address that demand, right? Building a semiconductor is the most high-tech, innovative type of manufacturing process literally in the world, right? You're taking sand and you're creating something that helps you communicate, in the instance of a cell phone, components that help you communicate over thousands of miles to people and to do video chats such as this, right?
Yeah.
So it's incredibly complex. You can't just make something that does that in a matter of days or increase that capacity. There's just sort of a law of physics that say, okay, lead times in the semiconductor industry and cycle times are X, right? And that's a constant. It's usually around 3 to 4 or 5 months or so, right? When there is capacity. So the industry, I think, has increased capacity. It just, as I mentioned before, 2021, the industry sold more chips, more units than in any other year previous, which was quite a Herculean task, given how long it takes to build fabs. And now the industry obviously is building new fabs, adding capex. I think in 2021, capex was at record levels, around 150 billion being spent in capex, and again in 2022. So the industry is doing what it can do in the ways that it can do it to meet capacity. So I think that's all moving forward. Obviously, one issue I think to kind of pay attention to, I think the demand environment again is, sort of rocky. And, we talk about, we see increasing inflation. The
Mhm.
geopolitical landscape is, sort of tenuous and sort of rife with, sort of troubles here and there. So I'm also just keeping an eye out on demand and looking to be sure that demand doesn't weaken. Because obviously, with demand weakening, that will also, sort of help with meeting demand. Though I don't think that's the ideal way to meet demand. But I think, given what's going on in the world in terms of the macroeconomic picture, is something to definitely keep an eye out.
Exactly, with inflation continuing, and
And it,
everybody thought it's going to be short term, but looks like it's here for some time. How that affects demand is going to be a crucial thing.
It's really funny for me, at least, to hear Falan say he's not worried about the short term supply, because that is, and hopefully not too controversial, but everybody we talk to within the industry doesn't seem as obsessed or concerned with the supply crunch as the general public is,
Uh-huh.
right? Because within the industry, there's kind of this inherent understanding
I see.
of how it operates, right? We're looking at a 2 or 3 year timeline. It is the law of physics, right? It doesn't get shorter. And so the question that is more relevant to us in the industry is, how do we build a robust business? How do we build a robust
Hmm.
signal that can propagate through the entire value chain for long-term planning? Right? That is the challenge that we want to address. The short-term supply shortage, is obviously kind of a dead sprint to try and meet the end needs, but there's very little that can be done, month to month, that versus what can truly be accomplished with a 3 to 5 year horizon.
Yeah, the whole idea is not to have this situation again, right? In the future, make sure the ecosystem is robust enough that this doesn't happen again. Right. So I think that's a great place to end our discussion. Again, thank you very much for coming over. It indeed was a very informative discussion. A lot of revelations, like for example, the difference in terms of the mature nodes versus latest node supply and demand. I know that was a very interesting revelation to me, going through the report and talking to you guys. And as you guys mentioned, the short will be there for some time, and hope to see you back on the show again, maybe in next few months or next year or so, to see where we stand, how the industry coped up with this, improvised and optimized for the situation that we are in. Thank you again.
Well, thank you, Prakash. Appreciate it.
Yeah, absolutely. Thanks for having us.
Sure. So, folks, that's all for now. I hope you found this discussion informative and useful. I'll be back very soon with another episode, putting light on another interesting tech subject. Bye bye for now.